To solve this system of equations, we're going to use row operations on a matrix. So first of all, we create a matrix that has two rows, since we have two equations, and it's going to have three columns. One column is for the coefficients of x, another column is for the coefficients of y, and then for the constants 1 and 2. So this first row is basically this equation without the x, the y, and the equals. So 2, -3, and a 1. And this one would be -1, 4, and 2. And now we're basically going to use the elimination method to solve for x and y. But we're not going to carry around the x and the y as we do it. If we were to go back to this and use intermediate algebra to use elimination method, we could say, well, multiply this bottom equation by a 2, making this -2x, add it to that equation and the x's will cancel, and then you can solve for y. Well, that's what we're going to do here. So I keep track of my work by saying I'm going to take row number 2, so this row right here, multiply by a 2, and then add it onto row number 1. And a lot of these calculations are done in our head. So we'd say multiply this by a 2, becomes a -2, add it to that, we've got a 0. So multiply this by a 2, becomes an 8, add it to that, and we've got 5. And then multiply this by a 2, which is a 4, add it to the 1, and we've got a 5. So the top row now becomes 0, 5, 5. And then what's different with this method, the Gauss-Jordan elimination, is we then leave the second row alone. So we use the second row to change the first row, but the second row itself didn't change. Okay, now this is basically saying we've got no x's, but 5y is equal to 5, which means that y is equal to 1. Or in other words, we should multiply 1/5 times row number 1 and get a 0, a 1, and a 1, which is really saying 1y equals 1. So the overall idea is use multiplication, or a combination of multiplication and addition, to get as many zeros and ones in here as possible. And when you get this to be just zeros and ones, then the solution is going to be sitting right over here. So next, with elimination, what I'm going to do is, now that I've got a 1 in here, I can use that, if I multiply by -4, to cancel this. And the good news is, since I've got a 0 there, then it's not going to change this to make it any bigger. So take a -4 times row number 1 and add it on to row number 2. So we're changing row number 2, but not row number 1. We're just using row number 1 to alter row number 2. So multiply this by a -4 and then add it to this, it stays the same. Multiply by a -4 is -4, add it to this, and we've got a 0. Multiply this by -4, so we've got -4, added to this is a -2. But the first row stays the same. And then, like I said, the goal is to get as many 1s and 0s as possible in this part, and when we do, what's left over here is going to be the solutions. Let me continue over here. So the next step is going to be get rid of this negative, so multiply a -1 times row number 2. And so the first row stays the same, and the second row multiplied through by a negative, and we've got this. Now this is saying no x's and 1y equals 1, so that's saying y equals 1. But usually we go in alphabetical order, that this is going to be the x information and this is going to be the y information. So one last thing to do is switch the rows. So 1, 0, 2 gets moved to the top, and 0, 1, 1 is moved to the bottom. And once that's done, then this is what x equals, and this is what y equals. And then we can even verify, go back to these equations. So 2 times the x value minus 3 times the y value is going to equal 1. Does that work? Well, this is 4 minus 3 equals 1. That's correct. And then make sure that it works for this equation. So negative of the x value plus 4 times the y value, is that going to equal 2? Well, that's a 4 and a negative 2. Sure enough, it does equal 2, and so we got it right.